To Wisdom Academy. Today we are looking at the trigonometrical ratio. We are looking at the trigonometry, and we apply what we call the SOHCAHTOA formula. Okay, the SOHCAHTOA, it's actually the SO stands for sine equal to opposite over hypotenuse, and the C stands for cosine equal to adjacent over hypotenuse, and the T stands for tangent equals to opposite over adjacent. So we're going to apply each of this one, and we'll see how it goes. Okay, for the next few minutes, let's listen to this. Okay, for you guys, if you don't hear it, don't worry, you will see it later on. Okay, so let's listen to this before we continue.
So in this tutorial we're going to look at trigonometry with right-angled triangles, otherwise known as SOHCAHTOA. Before we start, let's just make sure that we are doing the right thing. Here we have a right-angled triangle, and the key thing here is that we are working with two sides and an angle. If you're working with three sides, then you need to use Pythagoras theorem, and there is a whole other tutorial on that. And equally, if you are working with a triangle without a right angle, and you think you need to use trigonometry, you need to look at the sine rule and cosine rule tutorial. So, SOHCAHTOA. Why is it SOHCAHTOA? Well, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. SOHCAHTOA. Right, what are we going to do? Well, when we've decided this is the right thing to do, we're going to label the sides of the triangle. The hypotenuse is always the longest one, the adjacent one is the other one next to the angle, and then the opposite is the one opposite the angle. So pretty self-explanatory, but you do need to be careful. Once we've identified which sides we're working with, you need to choose the correct formula. Okay, each formula deals with a pair of sides, and you'll always be working with a pair of sides. So just choose the correct formula, write it down, substitute the numbers into that formula, rearrange it if necessary, and we'll look at how to do that in a minute, and then slap it in your calculator. We're not going to deal with that now, although you can find that somewhere else. Right, let's do, I think we're doing 3 questions today, so let's get on with it. In the first triangle, we're asked to find x, which is a side to 1 decimal place. Okay, so let's label the sides. The angle we're using is this 25 here, so everything will be labelled with respect to that. The hypotenuse is the longest side, so that's the 14. Here's the opposite, it's opposite the angle, and adjacent means next to, so x is the adjacent side. And we are using adjacent and hypotenuse, and so we need to use cos theta equals adjacent over hypotenuse. So write it down. Always write down the formula you're using, then the examiner knows what you're trying to do, and even if you make a mistake, he can give you some credit, or she, and they won't be able to give you credit if you haven't written down the formula. Right, substitute in the numbers. Well, theta is the angle, that's 25. Adjacent is x, and hypotenuse is 14. Now I'm not going to work out cos 25 at this stage. I'm going to wait until I've rearranged this. So how do I rearrange? Some of you will be able to rearrange that very easily. I'm going to go down the blue triangle route. So here's my blue triangle. If you're not sure about blue triangles, there is a whole tutorial on these. So what you do is you say cos 25 is x over 14. There it is, look. Cos 25 is x over 14. And then we can read off that x is equal to cos 25 times 14. And we can simply write that down. There are, of course, other ways of rearranging, but this is a pretty good one. So, x equals 14 times cos 25, And now I type exactly that into my calculator, and I get 12.7 centimetres to 1 decimal place. If you don't get that, check you've typed it incorrectly, and then check that you have a D or a DEG at the top of your calculator screen. If it says R or RAD or G or GRAD, you need to change the mode or the setup on your calculator. Right, question 2, only slightly different. This time it's the angle which is the unknown thing, but we do the similar sort of thing. So, label the sides. Hypotenuse is always a good place to start. The one next to the angle, that's the 12, so that's next to or adjacent, and 23 is opposite. Which two sides are we dealing with? Adjacent and opposite, so we are going to be using that formula. Tan theta equals opposite over adjacent. Again, writing down the formula is key. Now we put in the numbers and letters. So theta is the angle we're trying to find, which is y. Opposite is 23, and adjacent is 12. And again, I'm not working anything out yet. Now when you're trying to find an angle, you'll notice on your calculator that there is a tan to the minus 1 button. Well, actually it's the tan button, but you use shift tan, and you get tan to the minus 1. Okay, and you do tan to the minus 1 with a bracket, and we'll write down that this is shift tan. Okay, it gives you tan to the minus 1, and you put the bracket in, and you get tan to the minus 1 of 23 over 12, press equals, and you get 62.4 degrees to 1 decimal place. I'm going to do one more question, just because it's a slightly more difficult rearrangement, but basically it's still the same thing. So, hypotenuse, this time, is Z, opposite the 50 is there, and next to the 50, adjacent to the 50, is the 8. Again, which two sides are we using? Hypotenuse and adjacent, so we're going to be using cos theta. So write down the formula. Cos theta equals adjacent over hypotenuse, and stick in the numbers and letters. Cos 50 is equal to adjacent, which is 8, over hypotenuse, which is Z. And again, this is really where the blue triangle comes into its own, because this is a much more difficult rearrangement. So here we go. We've got cos equals 8 over Z, and I've abbreviated it appropriately. So cos is 8 over Z, but what do I want? I want Z, and that is 8 over the cos. Okay, now that would have been a more difficult rearrangement not using the triangle, so that's a pretty good idea. So Z is equal to 8 over cos 50, and again, just typing that into my calculator and rounding to 2 decimal places, I get 12.45 centimetres. And that is that. So if you are very methodical and always do the same thing, it's very difficult to go wrong.
Okay, so this one will appear later, you're going to see. So we introduced the 3 trigonometrical rules. We say that the sine is opposite over hypotenuse when you have a right angle. We always use SOHCAHTOA when we have a right angle triangle. Okay? If your triangle is not a right angle triangle, meaning you don't have angle 90, we don't use the SOHCAHTOA rule. We use the cosine rule and the sine rule. If your triangle is not a right angle triangle. So we only use the SOHCAHTOA when we have a right angle triangle. Okay? We only use the SOHCAHTOA when we have a right angle triangle. And we define the sine as opposite over hypotenuse from the SOHCAHTOA. Now let's go to the board and show this. So we have SOHCAHTOA. Now these are three trigonometrical ratios. They are ratio because something over something. The first one is sine. The full name is SINE, but sometimes we just write SIN as an abbreviation. The first one is sine, which is opposite. So opposite, I write, we abbreviate it OPP, okay, over the hypotenuse, which is the longest side. The opposite is the side that is facing the new angle, not the angle 90. Okay, the side that is facing the new angle, which we're going to see over the hypotenuse. So this is the formula for sine. The length of the opposite side over the length of the hypotenuse side. So this is the formula for sine. The second one is cosine, which is coa. This one is so. You can see this is so. This is so. So. This is so. S is the sine. This S is the sine. This O is the opposite. And this H is the hypotenuse. Okay, this is for so. The second one is the cosine. Okay, let's designate that with a different color. Okay, we say cosine, which we write cos as an abbreviated term. Cos, we write cos, okay? But for the purpose of clarity, let's write the full name first. Later, we'll be using the abbreviated name. Cosine. It's like sine, you put CO in front of it. Cosine is equal to, you look at it, K is adjacent over hypotenuse. This is the adjacent over hypotenuse. So we write the adjacent, we abbreviate it ADJ over hypotenuse HYP, okay, over hypotenuse. So when you have your adjacent over hypotenuse, we're going to show in a triangle so that you can get exactly what we're saying, okay? So this is, this stands for K. So K is cosine equal to adjacent over hypotenuse. The third one, which is TOA, the third one, which is TOA, is defined as follows. Then we change TOA, which is TOA means T is tangent. Tan. For the abbreviated term is tan, but the full name is tangent. Okay, tangent is equal to opposite. O stands for the opposite. Opposite over adjacent. A is the adjacent. TOA. Okay, over adjacent. Now, which side do we call the opposite, the hypotenuse, the adjacent? Okay, we draw the triangle to show each of all these ones so that we know the side we call the opposite, the hypotenuse, the adjacent, the whatever side that we're talking about. So let's draw a right angle triangle to begin to designate all of this. Let's draw a right angle triangle to begin to designate all of this. Okay, so if we draw a right angle triangle, this will be clear to us, right? Or clearer to us. Let's say this is our right angle triangle. This is angle 90. So if this is 90, already you know this is your hypotenuse. So already you know this is your hypotenuse. This is the hypotenuse. Okay, let's say if we put an angle here, if we put the angle we're looking for here, angle will normally use theta. If we put the angle we're looking for here, theta, this side, the one next to it is called the adjacent. The one by the side of the angle is called the adjacent. The one just by the side of this angle that we're looking for is the adjacent. Then the opposite to the angle, to this angle, is called the opposite. Okay, it's called the opposite. So these were the formulas all came by. Sine theta, so sine, if you're looking for sine theta, we say is the opposite over hypotenuse. This opposite over this hypotenuse. So sine theta is opposite OPP, opposite over hypotenuse. That's how we came about our SO. SO is sign of the angle is opposite over hypotenuse. The same way cos, which is cosine, cos, the abbreviated one, cos theta, if you're looking for the cos of this angle, cos theta is equal to this time around. Cos theta is not opposite, it's this adjacent over hypotenuse. Is the adjacent over hypotenuse for cos theta. Adjacent over hypotenuse. Then the last one, the tan theta, the tan of this angle is theta. The tan of this angle, tan theta, is opposite over adjacent. Opposite, because it's TOA, opposite over adjacent. Opposite over adjacent. So this is how we apply each of them. Okay, these are just a minute. This is how we apply each of them. Is that okay? Okay, so we say that okay, now let's look at the application. We've shown the three SOHCAHTOA. We've explained that vividly. We said the SOHCAHTOA is a sine equal to opposite over hypotenuse, which is SO. Cosine is adjacent over hypotenuse, which is can. And tan, tangent, is opposite over adjacent, which is TOA. And we've drawn a right angle triangle. We say when you're dealing with SOHCAHTOA, you must have a right angle triangle, meaning you must have angle 90. You must have this angle 90. If you don't have angle 90, that means we're not going to use the SOHCAHTOA. We use the cosine rule or the sine rule effect. We use the cosine rule or the sine rule to solve that problem. So, but if you have angle 90, we can use the SOHCAHTOA to solve any side or any angle that they want us to find. Now, without much time wasted, let's take a look at an example where we can apply this. So all this formula we've written already. The sine theta is opposite over hypotenuse. The cosine theta is adjacent over hypotenuse. The tan theta is opposite over adjacent from this triangle. We've demonstrated this already. We said the side of the opposite angle is this is the opposite. The side that is facing there, this angle. The side that is facing this angle is the opposite. The hypotenuse is the longest side, which is facing the angle 90. And this one is the side next to the angle theta. The side that is next to angle theta is called this one, this adjacent side. So we've put them in use. This is the SO, this is the CA, and this is the TOA. And this is how we use them. We've given the formula. If you're looking for the angle, for example, if you're looking for the angle theta, if you're looking for sine theta, in the end, you move sine, you find the sine inverse. It's like you divide both sides by sine, so this way becomes sine inverse. If you're looking for cos, you divide both sides by cos, you get the cos inverse. If you're looking for tan, divide both sides by tan, you get the tan inverse. However, this will be clearer the moment we take one problem. Let's take a problem quickly. As already demonstrated from the tutorial, that the application has been demonstrated, but let's look into it more extensively. You say find the value of x and y in the following triangle. We're going to look for the value of x and y in the following triangle. So here we have a triangle, a right angle triangle. We have an angle. We have two sides given and an angle, not three sides. You remember, if it's three sides that is given, we do what we call the Pythagoras theory. But if two sides is given, maybe you're to find one side and one side is given and one angle is given, you're going to use the SOHCAHTOA method. You're going to use the SOHCAHTOA method. So for this first diagram, let's quickly find x. Let's find x. We identify it and find it. Let's quickly find x. So here we have a triangle like this, a right angle triangle like this. Okay, we have a right angle triangle like this. x 943. We have here x. We have 9 here. And then we have an angle here 43. 43 degree. 43 degree. We have 43 degrees. So find x. Question say find x. So this is the angle theta, 43. Is facing, this is the angle. The side that is facing it, meaning x is the opposite. This place is the, here is right angle triangle. So here is the hypotenuse. So we identify each side so that it's easy for us. We identify each side so that it's easy for us. Okay? So here is the hypotenuse. Why? Because it's the longest side and it's facing the right angle 90. This is the hypotenuse, is the longest side and it's facing this angle 90. Remember here is angle 90. It's facing this angle 90. So this is the hypotenuse. This is our angle. Any side that is facing the angle is called the opposite. So here is our opposite. So here is our opposite. Okay? Here is our opposite. And then the side of this angle is called the adjacent. It's called the adjacent. It's called the adjacent. Now, we will think which formula are we going to use? Opposite over adjacent. You see, we don't have any value here. But we have a value here, we have a value here, which is opposite, meaning even if they did tell you a value, they put the x in there, they ask you to find the x. They're looking for x. So we say, this is the side they're asking us to find, this is the side they've given us, and this is the angle. So it's opposite over adjacent. So we use TOA, tan, 30, tan. So we simply say tan, use the TOA, this TOA, which means tan equal to tan 43. We write tan 43 because that's the angle. You must measure the angle. Tan 43 is equal to opposite, which is x, opposite over what? 9 over 9, which is the adjacent. Over 9, which is adjacent. Okay? So this is what we have. The next is to cross multiply or use the triangle rule. The next is to cross multiply, or we look at this blue triangle rule. If you look at this blue triangle rule, here is tan. Here is tan. And here is x. Here is 9. There's 9. So since you are looking for x, meaning you multiply these two, 9 and the tan. You multiply them. So it means x is equal to tan 43 multiplied by 9. Tan 43 multiplied by 9. Okay? So it means x is tan 43 multiplied by 9. Or another simple way, just say cross multiply. You know, this over 1. This over 1. You just cross multiply. X times 1 is x. And 9 times tan 43, you get tan 43. So you key into your calculator tan 43. Whatever you get, you say multiply by 9. So everything to one decimal place is what? Tan 43. Tan 43. Can someone press? Tan 43.
Teacher, minus 13.48.
Minus 13.
0.48.
We're not supposed to get minus, negative. Well, let's see. Press it again, tan 43. You're making a mistake. Press it again. Make sure that your calculator is in degree. If your calculator is not in degree, you get it wrong. So if your calculator is in degree, you're supposed to get 8.4 to 1 decimal place. 8.4. Okay? 8.4 centimeter to 1 decimal place. Okay, so that's how to find. You must ensure your calculators are in degree when you're doing this, okay? You must ensure calculators are in degree. Now let's take another example. This one. Example 2. Let's take example 2. We have 23 here, we have 8 here, we have y here. We have 23 in the longer side, 8 here. Well, so let's draw this one and look at this one quickly. If we have this, (23, 8y). Okay. We have y degree here. Here is degree. Here they're asking us to look for the angle. Probably they're asking us to find the angle. We have 23 here. And then we have 8 centimeter here. We have 8 centimeter here. Okay, so if you look at this, the opposite is here. So we not they did give us the opposite. They didn't give us anything on the opposite side. So this beside the angle, this angle is adjacent. So here is adjacent, and here is a right angle triangle, which is your angle 90, and here is your hypotenuse. So here is our hypotenuse. So if you look at it, we have adjacent over hypotenuse, which is what? Cos. Right? Adjacent over hypotenuse, so we say cos y. So the formula to use is cos. Cos y. Cos y is equal to the adjacent, which is 8, over the hypotenuse side, which is 23. So we're using car. You know, car means cosine is adjacent over hypotenuse. This is the part we are using in the SOHCAHTOA. We are using the car part of it, okay, for this question. So the next thing is to find y, right? So to find y, we have to take the cos of both sides. Maybe saying divide both sides by cos. Divide both sides by cos. Okay, I will explain to you why we always have cos minus here. What it means is that we divide here by cos. We divide here by cos. You know, when you divide here by cos, it becomes 1 over cos. You know, cos will be at the bottom. So this cos we cancel this cos, y will remain on the left. So on the right, 1 over cos means cos inverse. It means cos inverse. Are you with me? It means cos inverse. 1 over cos in indices. Okay, it means cos inverse. If you say 1 over a in indices, it means a raised to power minus 1. It means a raised to power minus 1. We remember this. We remember this simple rule in indices. So here, 1 over cosine, it means cosine raised to power minus 1. So 8, you now write 8. You put it in bracket. You have to put this in bracket. If you don't put this in bracket, you might be wrong. Your calculator may not factor it correctly. Okay, so this is what we do. We key in the calculator 8 divided by 23. Whatever we get that. We'll find the cos inverse of it. Not the cos of it, the cos inverse of it. So that we can get the angle in degree. Because when you find cos inverse of anything, in trigonometry, you can get the angle in degree. So let's find the y in degree. 8 divided by 23, whatever you get, you find the cos inverse of that number. You're going to get 0 point something, something, something. And then you find the cos inverse of 0 point something, something. And you're going to get an angle which is 69.6 to 1 decimal place. 69.6. Put key in your calculator pause and key in your calculator, pause the video and put the values in your calculator and see whether you get 69.6. To 1 decimal place. You put degree, 69.6 degree to 1 decimal place. Okay? So let's apply the same problem. Let's look at another example. Yeah, 69.6. So that's the value. Okay? Now we take a look at this example we've seen before. We solved this example before. It's in this one below. AB is 12. We solved this problem. AC is 9 and AC is a straight line. AD is 9 and AC is 22. Okay, here we use Pythagoras to solve this. And then they want us to find angle. The only part we want to find is angle BCD. BCD, this angle. They want us to find this angle, right? We've solved this problem before. I think, but the only thing they shade it here is to find this angle BCD, right? BCD, this angle. So, but before we find BCD, we have to find BD. We solved for BD before, 7.94. We solved for BD before, okay, in our previous video. So let's quickly take a look at it. They want us to find angle BCD. Find angle BCD. Let's solve this problem again, right? But because this case, this time around, they're looking for something different. So they want us to find angle BCD. Let's assume this is our triangle. This is B. This is C. This is D. Obviously A. Here was 12. Here was 9. The whole of this was 22. The whole of this was 22. So we don't know BD. We found BD before using Pythagoras theory. Here was X. And then they asked us to find angle BCD, this angle. We can call it theta. We can call it theta, this angle BCD. Find angle BCD. B, CD. Put this on top to show it's an angle. Find angle BCD. So before we can find angle BCD, we have to solve for BD. We have to solve for BD, right? And we already know here. We say here is 22 minus 9 because the whole length is 22, AC. Length AC is 22 and this length is AD is 9. So to find here, you say 22 minus 9. 22 minus 9, which gives us 13. So here's 13. But to find BD, because we can find this angle, we have to find here and here. So we can now apply any of the trigonometrical ratio. So we know here to be 30, we have to find here. Here, the longer side, because this is right angle, this is a right angle triangle, also this. So we have two right angle triangles just joining together, be put together next to each other. So we have to find this BD, we have to say the longest side square minus one of the short side square, which is 12 square. 12 square minus 9 square, right? 12 square minus 9 square. So which means this gives us to find BD. BD square is equal to 12 square minus 9 square, which gives us BD square. Okay, if you did get the hang of it in the previous case, this is time for you to get it. BD square, this is 144. 12 square is 144, minus 9 square is 81. 144 minus 81, I think we get 63. right? 63. This gives us 63 because 4 minus 1, you get 3. 14 minus 8, you get 6. So you get 63. Okay, so you find the square root of this BD, the square root. If you take square root of both sides, you get this one to be 7.94. Approximately 7.94 to 2 decimal places. Okay, that's what we get for this case. We get our BD. We get our BD to be 7.94. Why do we have to find BD? Because we want to solve a problem on this side. We must get the parameters on this side so that we can find the angle. We cannot have two unknowns. Okay, we cannot be looking for two unknowns. So we have to get at least 2 numbers to find the third number, to be able to find the third concept. So we quickly use this triangle. Here we have 2 sides. We find the third side which connects to this other triangle. And then we also use the length of this one minus this 9. We get the length of this, which is 30. Now you know here, opposite over adjacent is tan. So we can say tan 30, which is BCD now. BCD means this angle. When they say BC, it means the one in the center. BCD, if you are wondering where is angle BCD, you trace B, you trace C, you trace D. Out of the 3, the one in the center is the angle they're talking about. So the angle at C, which is this place, this angle at C, that's the angle they're talking about. So we just represented this angle with a theta. We represented the angle with theta, so that it's easy for us to do. So what we have, we can redraw that small part of this, what we are left, so that we'll not be confused. This is what we are about to do now. This is the triangle of what we're about to do, okay? The right angle triangle of what we're about to do, the final part. Here is 30 centimeter, and here is 7.9. 7.94. If you like, you leave it in 1 decimal place. 7.94. Okay? So here is 30. And they are asking us to find this angle. Angle C. Or you call it angle theta. Call it angle theta. So this is what we've been asked to find. Here is our B. And here is our D. So this B, C, D. They're asking us to find this angle. So if you look at only this one, if you separate it from the whole of the 2 triangles, 2 right angle triangles, if you bring this one out, it's clearer to you. So you can see, holistically, you can see that you know this side. This is the opposite. We know this is the opposite. This is the opposite, right? And this is the adjacent beside this angle. It's called adjacent. So opposite over adjacent is called TOA, tan. So we say tan theta, or tan C is up to you what you want to use. Or tan BCD is up to you, same thing. Is equal to 7.94 over 13. So since you're looking for here, what you hear is already the subject or formula. You just divide this. But the only thing you introduce here is that you divide both sides by tan. So you have theta left here. Only theta left or the left. And then when you divide this side by tan, it becomes tan inverse. It becomes tan inverse. I showed that in the previous case, how it became inverse. So it becomes tan inverse into, it means tan raised to power -1. Becomes 7.94 or 7.9 over 13. So you divide this on your calculator and press the tan inverse. We get the angle. Quickly. Can someone get that for us? We get that quickly. You put it in the calculator, and then we're able to find angle about 31, right? About 31.4 to 1 decimal place. Our angle will be 31.4. So confirm, pause the video, and confirm if you get this angle 31.4. If you didn't, it means you made a mistake. You go back to it again and see how to key in a calculator. You can divide this number first, This divided by this, whatever you get, you find the tan inverse of the number. The tan inverse of the number you get. Don't forget to write your degree on it, showing that it's an angle. Show you that it's an angle. So angle BCD, 31.4, okay. BCD is equal to this. Angle BCD is equal to this. So in case you're asked to calculate this. So these are the application of trigonometry. These are small application of using the cosine rule. Using the cosine rule. Okay, applying this, the SOHCAHTOA, sorry, not the cosine rule, applying the SOHCAHTOA. This is how we apply the SOHCAHTOA to be solving the different problems, okay, in trigonometry. This is how we apply the SOHCAHTOA in solving the different problems in trigonometry. Okay. Then, you can also use this one. You know, we found the BCD. I think they also extended the question. Probably they asked us to find something else. Let's see what else they asked us. dx. So they link d to x. And then they asked us to find dx. We already know this one, right? Okay. So to find dx, we can use, we can say the sine of this angle. To find this dx, you say sine of this angle, sine, you know this is opposite over the hypotenuse. This is the hypotenuse side. Let's say, for example, let's redraw BCD triangle. Let's draw it again, and let's find dx. These are B, this C, this D. And then they mark X here.